Okay, let's dive right into this. Welcome to today's explainer. We're basically going to be playing Cosmic Detective today, and we are looking at the ultimate crime scene, our very own universe. For decades, we've had a really solid set of rules, right? These established models of physics and cosmology that supposedly explain how everything works, from the tiniest atoms all the way up to massive galaxies. But lately, well, the universe is actively breaking those rules. It's dropping clues that simply do not fit the narrative we've built. So we're going to investigate the absolute most confusing discoveries in space right now.
To start us off, I actually want to ask you a kind of weird question. Have you ever tried to unscramble an egg? I mean, really think about it. You take a whisk, you scramble it all up, you cook it in the pan. You literally cannot reverse that process. It's a one-way street. And trying to peer back into the incredibly chaotic early universe is exactly like trying to figure out what a perfectly whole, pristine egg looked like by just staring at a plate of scrambled eggs.
There's this quote that just perfectly captures this dilemma. To take a whisk and stir it backwards through your breakfast and somehow end up with a perfectly whole yolk, we exist in a universe that has been churned. Our brightest minds are out there using the most advanced tools humanity has ever built, like the James Webb Space Telescope, to try and piece together this cosmic scramble. But here's the catch. The deeper we look into the past, the more the pieces refuse to fit our established models. We're finding these wild anomalies that are forcing us to question absolutely everything.
All right, Section 1, the scrambled universe.
This brings us right to our first major investigation. We're looking way back at the dawn of everything, a time where our standard Big Bang prediction should honestly be our guiding light. Instead, they're spectacularly failing us, particularly with this massive discrepancy that scientists call the lithium problem. See, our mathematical models of the Big Bang are incredibly precise. They predict exactly how much hydrogen and helium should exist out there, and those numbers match what we actually observe perfectly. But our models also predict really high levels of lithium-7. In reality, though, we observe 3 times less lithium-7. And it gets even weirder, because there's 1,000 times more of the rare isotope lithium-6 than there should be. The math is just in deep, fundamental tension with reality, and it's forcing us to totally rethink the basic chemistry of the early cosmos.
And honestly, it gets even more confusing when we start looking at the age of things. Think about the number 14.5 billion years. That is the estimated age of a specific star known as the Methuselah star, which is located just 200 light-years away from us. Okay, so the crucial point here is this. Our absolute most accurate measurements put the age of the entire universe at 13.8 billion years old. So, how on earth can a star be older than the universe it actually resides in? Even if you factor in the margins of error, this glaring contradiction tells us that either our entire timeline of the universe is just wrong, or our understanding of how stars age is fundamentally broken.
Moving on to Section 2, planets that defy physics. So the universe isn't just breaking the rules on a grand cosmic timeline scale. Recent discoveries, especially the ones kicking off around 2026, are completely shattering our understanding of how individual planets form and survive. Let's zoom in a bit and start with our closest neighbor, Venus. We always call it Earth's twin, right? But in reality, it's a toxic, high-pressure wasteland. The upcoming ESA Envision mission, which is heading out in the 2030s, is designed to solve some just incredible mysteries. Like, is there ongoing active volcanism happening there right now? How are those incredibly thick sulfuric acid clouds sustained without just dissipating away? How does the planet lose its internal heat without having plate tectonics like we do? Where did its ancient oceans go? And how does its supercritical atmosphere, where the air is pressurized so much that it actually flows like a liquid, weather the surface? Understanding Venus might actually be the key to explaining why Earth became this lush paradise while Venus turned into a literal inferno.
Now, if you want to see how extreme planetary conditions can really get, we have to talk about exoplanet PSR J2322-2650b, discovered by the James Webb Telescope. This thing is orbiting a pulsar, which is a dead, highly radioactive star, at an incredibly close distance. The gravitational tidal forces there are so absolutely brutal that the entire planet is stretched into a literal lemon shape. No joke. It completes a whole year in just 7.8 hours. But the wildest part? It completely lacks water and methane. Instead, it has a carbon-oxygen ratio over 100, featuring massive soot clouds and, because of the insane pressure, potential diamond rain. I mean, this completely defies all known theories of how a planet could even survive under such extreme radiation.
From the destruction of planets right down to their birth, we have to look at another staggering number, 400,000 million miles. That is the diameter of Dracula's little goat. Yeah, that's the real name.
It's the largest protoplanetary disk ever observed by the Hubble telescope. This massive ring of gas and dust is 40 times the size of our entire solar system. It proves that stellar nurseries are these wildly chaotic environments with enough mass to form up to 30 giant gas planets. The sheer, mind-boggling scale and the asymmetry of this disk show us that planet formation is just way more dynamic and messy than our standard neat little models ever predicted.
All right, Section 3, Black Holes Breaking Time. Moving further out into the dark, we have to talk about the monsters of the cosmos. We are finding black holes that are growing and existing in ways that literally defy the established laws of physics. To really understand why this is so crazy, we first need to define the cosmic speed limit for eating. It's called the Eddington limit. Think of it as the maximum brightness and feeding rate of a star or a black hole. Basically, when a black hole eats matter, that matter heats up and emits intense radiation. The Eddington limit is the exact point where that radiation pushing outward physically blows away the food the black hole is trying to pull inward. It is supposed to be a hard physical limit on how fast a black hole can possibly grow.
So the standard Eddington limit is our absolute maximum, right? Well, the James Webb Space Telescope recently observed a black hole named ILE D568 feeding at 40 times that limit. 40 times! It's kind of like watching a competitive eater consume 40 hot dogs in the exact time it takes to swallow just one. This discovery is a huge deal because it brilliantly illustrates a brand new theory. Perhaps the supermassive black holes in the early universe didn't just grow slowly from dead stars like we thought. Maybe they skipped the stellar phase entirely, collapsing directly from massive clouds of dust, which allowed them to grow impossibly fast.
And speaking of impossibilities, Quantum magazine recently reported another massive James Webb discovery. A solitary, naked black hole wandering around in the very early universe. This absolute monster is 50 million times the mass of our Sun, but it's totally, completely alone. It completely lacks a host galaxy. Now, standard cosmological models say that galaxies and supermassive black holes co-evolve, right? They're supposed to grow together. Finding a massive black hole just wandering alone out there in the early universe completely upends our entire timeline of how these structures supposedly formed.
Which brings us to Section 4, the missing cosmic matter.
So what connects all these broken models, from the missing lithium to these impossible black holes? Well, it all points directly to the invisible scaffolding of the universe. We are actively exploring the dark universe right now on multiple fronts. We actually have new data suggesting dark energy, the mysterious force pushing the universe apart, might actually be weakening over time, which literally changes everything we thought we knew about the ultimate fate of the cosmos. We're also searching for primordial black holes from the dawn of time. We're hunting for theoretical ghost-like particles called axions and sterile neutrinos. And starting in 2026, the Vera Rubin Observatory is going to use these instantaneous data pipelines to map the sky every few nights, specifically hunting for gravitational anomalies. We're even watching violent events like ram pressure stripping in galaxy NGC 4388, where gas is being violently torn away, just to see how dark matter shapes those interactions. The current thinking right now, dark matter probably isn't just one single thing. It's much more likely a really complex, messy mix of unseen particles and ancient black holes.
Because of all these totally baffling physical anomalies, some major thinkers are actually proposing a complete paradigm shift. The Club of Rome recently published a fascinating paper on what they call unitive science, and they argue that the universe isn't just a collection of separate mechanistic parts bumping into each other. Instead, it is fundamentally relational. It's interconnected by these intricate fractal patterns that repeat all the way from tiny atoms up to massive galaxies, governed by power laws, and linked together by quantum entanglement across vast, impossible distances. They're essentially suggesting that to fix our broken models, we might need to view the universe as a deeply interconnected, perhaps even living, system.
Finally, Section 5, Rethinking Reality Itself. To wrap up our cosmic detective story here, we have to look at the absolute biggest broken models of all. If our universe is acting strangely, maybe it's because it's just one tiny piece of a much larger, way weirder puzzle. Take Max Tegmark's 4 levels of parallel universes, for example. Level 1 is just an infinite space with identical copies of us out there somewhere. Level 2 features regions with totally different physical constants, so maybe there's a place out there where that solitary naked black hole makes perfect mathematical sense. Level 3 is the quantum many-worlds interpretation, where basically every probability branches off into its own reality. And Level 4, that is a reality governed by entirely different fundamental mathematical equations. If the laws of physics vary that wildly out there in the broader multiverse, it might actually perfectly explain the weird scrambled anomalies we're seeing right here in our own little pocket of space.
But what about time itself?
Nobel laureate Roger Penrose offers this absolutely breathtaking theory called conformal cyclic cosmology. Here's how it works. Step 1. Our universe just expands and cools eternally. Step 2. Over trillions and trillions of years, all the black holes eventually evaporate into absolutely nothing. Step 3. All that is left in the entire cosmos is massless radiation, just photons. Now, Step 4 is the real kicker here. Massless photons moving at the speed of light literally do not experience time or spatial distance. So that leads to Step 5. The universe essentially forgets its own size and scale. A vast, infinite, empty universe mathematically becomes totally indistinguishable from a tiny, infinitely dense singularity, which triggers a brand new Big Bang. The ultimate end of our universe literally becomes the exact beginning of the next one.
Which brings us to our final, pretty provocative thought for this explainer. If a universe made purely of light eventually forgets its own size, and the end directly triggers the next beginning, did it ever really have a beginning in the first place? Or has it just always been churning? It ties right back to our scrambled egg from the start. We're trying so hard to find the origin of the egg, but maybe there never was a first egg. The universe is actively challenging us to rethink not just our physics, but our fundamental concepts of reality itself. It really leaves us wondering, are these cosmic mysteries ultimately meant to be perfectly solved by our equations, or are they simply meant to be marveled at? Thanks for joining me on this deep dive today, and keep looking up.